Hello, everybody. So, I'm going to finish up software today. And this is another one I'm probably going to constantly look at my notes because normally I teach some more advanced software development courses. And I definitely don't want to accidentally go down a deep rabbit hole and leave everybody very, very confused. So, probably a short day. We're going to look at some examples. Nothing too fancy, just some basic coverage of using the IDE and some basic points on the languages we're going to look at. Not get into depth on them. A note that I want to make. Oh, I have a note here. Registration for the spring semester is open, so please register sooner rather than later. The advisors are expecting to be very, very busy. So I think they're all scheduled for extra hours this week and next week when it first opens. And then again, that last 3 or 4 days before the spring semester starts, the time when everybody actually goes in and registers, the advisors will be scheduled for extra hours again if you need to talk to them. But please remember to register, and sooner is better than later, because if there's low enrollment in the classes, we start canceling those classes at a certain point, so that the people who are in there, if there's not enough, if there's only like 3 people in the course, there's plenty of time for those 3 people to register for another course. And I've seen it happen before. When was it? I think fall 2019. I was supposed to teach the PHP course in the fall, and there was only 1 person registered. Well, that person needed it to graduate. We kept pushing it back as far as we could, and then finally it was only 3 or 4 days till the class started, and there was only 1 person registered, and it's like, well, I'm gonna have to take it online instead of in the classroom. And then starting Friday night, between Friday night and Sunday, the dean and I both got like 5 or 6 emails each about people wanting to register for that class and wondering why it wasn't on the list anymore. And we're like, well, we canceled it because nobody signed up for it. So signing up for classes sooner better than later is definitely a good thing, because you don't want a class that you need to take to get canceled on you. And especially on campus, we have a lot of classes that we need to run, and only a couple of labs to do those in for the blended and learn anywhere courses. So a lot of those are on like a 2-year cycle. So it might be a while before you see those classes come back around. So please register as soon as possible. Please don't wait till the last minute, because lots of people wait till the last minute. So if you need to talk to an advisor, it's even hard to get in and talk to your advisor. They might only be able to find 10 or 15 minutes to squeeze you into their tight schedule, and have to rush through that 10 or 15 minutes. So sooner is better on that. So then make that note. And on some of the labs I've seen this week, I was going to talk about those some today near the end. One thing that I saw was it looked like some people were following along with what we'd looked at earlier with keyboard shortcuts. Well, you probably haven't done that before, but then I saw a couple times somewhere in the middle of using all those keyboard shortcuts and writing that out is had to stop and select with the mouse. And I was like, oh, I forgot to show them that one. So even though we're going to look at a couple of those things, I wanted to make sure and address that note first, because, well, the reason we looked at those keyboard shortcuts to begin with is we have much more control with the keyboard. And most of you all are probably too young to remember this, but before every computer had a mouse, to highlight and select things, we would use the shift key and the navigation buttons. So like the arrows, page up, page down. So if I open the file explorer, remember Windows E will open that, then Alt D here on the Windows machine, since there's an address bar, we can push Alt D to get to the address bar. For the Mac users, Command L will put you in the address bar anytime there's one there, and that's a really good way to navigate around. And oh, I was trying to do it this way. So go up here and go into the like documents. Do I have anything in my delete folder? Yeah. So if I want to select this, what I usually do is I'll push Alt D to go back to the address bar and then tab 3 times to get to that main area. And we can move up and down. And if you want to highlight those without using the mouse, you hold your shift key and move the arrows up and down. The arrows, the page up, page down, home and end keys, those are very useful. The home and end keys are something you're especially going to want to get used to. They're in a different spot on every keyboard, and you probably haven't used them much. But heading into IT, especially software developers, you're going to use those keys a little bit more often. So it's another useful one that kind of fits with this. So if we had some, say, Python code, this is what we're going to look at here in a minute. Just write a little method. Should write that correctly. Print hello world, nothing fancy here. Main is equal to main. Run that. So nothing too fancy here, but what I wanted to look at was with the highlighting. You're probably used to dragging your mouse around and clicking and dragging, selecting just the words you want. But if you want to do that without using the mouse, because we have way more control with the keyboard, you'll use the shift button. Oh, sorry, I didn't see the question pop up. Quick question. Are we going to be learning how to use Java later on in the year? Probably not looking at Java in this class. I'm teaching the Java class this semester, and it's being recorded just like these classes are. So I can send you the one from my evening class. I'm gonna go teach Java at 6 o'clock tonight. That's what I drive up to campus for after this class. And I will definitely be available if you have questions on that, Dylan. Feel free to send them my way. That's learning IT. We're here to learn IT, and I'm here to answer IT questions. So I'll make sure you have the links to those other videos as well, and to my evening class. And we're probably going to look at Python. It's a whole lot easier to work with. And for a long time, it was a problem because it's easier for the human because it's more for the machine, so everything's slower. But as machines have gotten faster, we care less and less about that slower part and go with the one that's easier for the human to work with. But there are still a lot of advantages of the more powerful languages. Oh yeah, selection. So if we wanted to select a line, you're probably used to bringing your mouse up here and clicking and dragging over and getting all that, and then Control C and Control V, all the normal copy paste stuff. But with the keyboard, a really quick way to do that, and this is a useful trick for software developers, just click anywhere in that line. And then if you hit the end key, your cursor will go to the end of it. The END, it's end and home are usually on a different spot on every keyboard. Probably over on the right-hand side if you're on some sort of laptop. If you're on a Mac, it might be function right arrow for the end and function left arrow for the home, or depending on your keyboard layout, you might have to use the function or keyboard combinations to get there, but it'll be on your keyboard somewhere. And then once you have your cursor at the end, you hold shift and hit home, and that'll select that line really, really quick so you can copy and paste it. That's something that happens a lot in software development. And I always do the end of the line first. So just click anywhere on it, or use the arrows once you get used to using those with your pinky really effectively. Then when you hit end, your cursor's at the end and you hold shift and hit home. And I go to the end first because if you hit home again, the home key toggles between indenting. So that's a really useful way to highlight the line. I've already seen that a couple times and realized that wasn't in the keyboard shortcuts we talked about earlier, because it was a sudden break in the ones I've seen as people were writing up how they made the files, going through all those keyboard shortcuts nicely, and then suddenly that other one that's using the mouse again, and I was like, oh, I forgot to mention it that day. So yeah, so most of y'all are probably way too young to remember that. We're going to talk about the mouse and stuff before long. I remember seeing that in the discussion board, but since I teach IT, I'm preparing people to sit at a desk. So I always like to take a few minutes in every single class I teach and talk about ergonomics and things like that. And we'll talk about the history of the mouse and history of the keyboard and some other stuff when we get to that. Usually it takes about 20 minutes. We'll probably see it soon. But the original mouse is kind of an interesting story, but sitting at a desk working on a computer is actually really bad for our bodies. The human body is a dynamic thing. Sitting at a desk working on a keyboard damages our body just like we're getting injured on a dangerous job site. Very badly when we do it for like 30 years in an entire working career. So we'll talk about that stuff soon. I guess now into some points about software. Does anybody have any questions before we get started into our main topic stuff for today?
No.
Okay, so there was one thing on the notes that didn't make it in there the other day, just a picture I wanted to draw on the board. Mostly we're going to be doing an example, and unlike last week's example, today's example will be easy to follow along with. Last week I wanted to jump up to the more advanced stuff to show you kind of a preview of where you're heading on that, which made it really hard to follow along. But today's example is designed to be a follow along one, so make sure you're set up to do a follow along thing. I just wanted to put a picture up here about operating systems. So as you progress through IT, an operating system is kind of a big, complicated thing. We're not going to go over every detail today, obviously. When I got my IT degree from Ivy Tech, it was in computer information systems 8 years ago, I think 7 years ago. I had to take an entire class specifically on operating systems, but we don't seem to have that class anymore. I keep bringing it up. It's like, can we bring back a class like this? Because a class entirely on operating systems was a really, really useful thing to have. But what I wanted to do is just sort of a brief overview, introduction, and as you progress through things, you'll see different pictures. And there's one picture that I really like to introduce kind of what the operating system is and hopefully give you a step up from what you already knew about operating systems. So we talked about hardware, right? I'll put that in the center. And you'll see lots of different diagrams. I can explain stuff. This is one I think is easy to start with. I always call it the onion diagram. It makes it easy to visualize stuff. But we talked about the hardware. So that machine is made up of our CPU. I'm going to draw the actual pictures. Instead of just a box there, I'm going to do a box with double lines on it. Our RAM is just a box. We have our storage. Hard drive, probably mostly solid state drives anymore. The picture is supposed to look like a stack of the old reel-to-reel tapes, or maybe even a stack of discs. The official thing on it says it's supposed to look like a stack of reel-to-reel tapes, but those were like 20 years out of date before they standardized the picture. So maybe a stack of disk drives for our long-term storage, and all those hardware things. I guess there's a keyboard in there somewhere. I'll just write that as a word. We talked about all that stuff. You all are somewhat familiar with that. Could fill up the board with that picture. I'll stop there, I guess. Into the list. And that hardware kept mentioning binary code and stuff. That's the part that's really hard for a human to deal with. That's what the hardware needs. Furthermore, the hardware is what the electrical engineers deal with. So that's our main type of software. The first layer of software, what we're talking about this week, is some software to interact with that hardware on our device. And there's like multiple layers of it. So surrounding the hardware, kind of close at the closest level to the hardware. So a step above the electrical engineering, so getting into computers specifically and away from the electrical parts directly, we have what's called the kernel of the operating system. And that's those basic core commands that interact directly with the hardware. So the kernel kind of has access to that hardware. And surrounding that, the reason I always call these the onion pictures, there's going to be layers and layers and layers of software. Like I'm about to run there, but lots of layers, kind of like the peels in an onion, just layers and layers and layers of software. And finally, way out here somewhere is where our high level language would go. The part we are actually going to work with. It's an abstraction completely separate from our operating system. And the high level language can interact with our operating system. And then that operating system software pass it down through the levels till it gets to the kernel, directly interact with the hardware itself, and then pass the response back up through those layers to that high level language. And that's the human level interaction. So we're usually way out here, like completely outside of it. And you notice I only wrote one vocab term here, the kernel of the operating system. So that innermost layer, the one that's directly interacting with the hardware, we call that the kernel, and that's the deciding factor on what type of system we have. So our operating system is going to be a Windows kernel or an OS X kernel or a Linux kernel. Mostly those three. There are other ones, but in our modern world, it's pretty much those three anymore. Chrome OS and Android are Linux networks, so they're just very, very customized Linux systems. With that kernel, the operating system kernel decides what type of machine we're working on. That's usually what we refer to, right? We ask that question. I'm pretty sure I've asked it in this class directly, like, what type of machine are you on? And everybody would say Mac or Windows or a PC, or give some sort of response. But when I asked that question, you knew I wasn't talking about the hardware, right? Well, in the module 3 lab, we were directly talking about hardware, but it was explicitly stated over and over again that this question is about the hardware, not what we would normally say when we just say on your machine. So the operating system kernel is what defines the type of machine. Kind of back to that vocabulary thing. And then in the onion, I always call these onion pictures. Way out here past all the layers of software, adding more and more abstraction or removing more and more abstraction. We don't need the super detailed version of that, whichever way makes more sense to get us away from that binary code out to the level that humans think of. There's a word there called abstraction, but whichever way using that word makes sense in your mind right now, whether we're adding it or removing it, each layer is going to do more and more of that until we get out to a part a human can work with. And that's what we want to look at today, because we feed our instructions in here. We tell the computer what to do when we push the G key on the keyboard. We explicitly set up some instructions. When that G key is pressed, the kernel of the operating system is going to detect it and pass that out through the layers and check every piece of high-level language software that it knows about to see if any of them are waiting for the G key to be pressed at that particular moment. And when it finds one, it's going to send it back down to the hardware to respond appropriately. So just introducing that concept, the main things, the terminology. So the kernel of the operating system is the part that directly interacts with our hardware. And then there's layers and layers and layers and layers on top of that. So lots of other vocabulary terms to work in throughout your IT education. And then we get out to past the operating system where we're talking about individual programs, which is what today's example is about. So I'm just going to do it as an example. Programming is very much an active subject. We learn by doing. So it's a good one to follow along with. And you should be able to follow along without any problem. I'm going to do this right on that Ripple IT site that we looked at the other day, instead of locally or with some other software that y'all might not have. That's a really convenient one to work with. And yes, the question showed up earlier that if you want to go ahead and do your HTML code there too, because if you type your HTML there, it'll change colors and you'll get some predictive text to make things easier to work with. Let's look at that. You'll follow along examples. So with HTML, we're encoding our data. We're saying what our data looks like. So here's just some words printed out. If I run that, we just get some basic text, but I could change that up a little. I could say this paragraph, and note, I only typed that part. Actually, let me erase that so y'all can see what's going on there. We have these in HTML, we had what we call tags, angle brackets. So you can see where the cursor's at. I only typed that far and it finished typing some more stuff for me. It knew I was going to need, well, if we created an opening tag, tags come in pairs, so the computer knew there had to be a closing tag at some point. And you can type those words, and then the P stands for paragraph, so show that as a paragraph on the page, which is kind of what it did by default. I guess it added a little bit of padding there. I was like, oh, wait, wanted that great big and bold. So instead of a P, I could type H1. And notice how it pops up that little box predicting what I was trying to type and things. So we have the angle brackets are greater than, less than symbols from math class. The head of an arrow, those symbols with some in between. What we're doing is saying specifically what type of data we have. So here's our actual data, the words we want to put on the page. And then this is type instructions on how we're going to format that. So instead of a paragraph, now it's a level 1 header. So great big text and bolded, and we encoded our data differently, formatted it. So there's a lot of that, and I'm pretty sure almost everybody has to take the SDEV 153 class. So you will see markup languages. That's what the ML at the end stands for there. Markup language. Back when I was young, my first exposure to markup languages, this would have been the late 80s, probably long before any of y'all were born. There was a time when our printers could do way more than our monitors could. The monitors were those little cathode ray tubes, and we had huge pixels on them. We couldn't get much detailed. If you go to a museum like an Apple II, back in the days of Apple IIs, because yeah, when I first learned to program was on an Apple II, and it was back in those days. If you've seen pictures of those in history books or museums, but our printers were really, really nice at the time. We did have some nice printers, just so we could do more when we hit print on the page than we could when we viewed it on the monitor. So we would use markup languages in our document editors to indicate how that text needed to look whenever it got to the printer. And then within 3 or 4 years, we were able to do that on monitors. And that's when the internet as we know it was developed. Because for a long time, it was just an internet, but nowadays it's the internet. Because we're going to talk about networks next week. We'll talk about what that change in the article that happened around 1989, 1990. But it gives us a way to include extra information on how that data is supposed to be encoded when it gets printed out. And your lab is step-by-step instructions on writing some HTML code, kind of like the other labs. This is primarily a vocabulary class, but we want to do interesting things while we're learning that vocabulary, right? We can learn vocabulary in methods other than typing essays. So you'll see step-by-step instructions on putting some of those tags in there, and it kind of makes a nice middle ground between the perfect form for computers without adding a lot of extra work for the human. Because on this data that I just said is H1 data here, we explicitly say where it starts, where it stops. We have the data itself, and I have to point at one of the other tags. And along with that, inside of this opening tag up here, you can see we also have some metadata about it. So we have the start point, the stop point, some metadata about it, and the data itself. So it's a really good form for the computer, and just doing that in those little tags isn't much extra work for the human. And obviously we can have the computer type those tags. I kind of pointed to that with predictive text, and we can do way more than just a predictive text to finish out what we're typing, but it's really easy when the computer types all the tags for us. But it makes for a good middle ground between not too hard for the human and a really good format for the machine. And otherwise, and it's all done just straight it's just straight Unicode passing through the machine, which is might as well talk about this. So UTF-8 is Unicode. You've probably heard that word in our society. And now that you're moving into IT and you might need to actually type it in somewhere, if you're going to explicitly ask a computer for Unicode, it's UTF-8. Yeah, I guess it could also say, it might seem strange, but those letters and number are how we spell Unicode. And that will be an important one anywhere you're heading in IT. Because that's the symbols from our keyboard straight into the computer. So a useful thing there. We probably will want to look at the more dynamic one, right? That's encoding, making things look nice. Some people really, really like that. We have several certificates, CTs and technical certificates, CTs and TCs, along with the AS and AAS degree that would focus on web application stuff. So if you're just really interested in making things look really nice and happen on the web, let me know later, and I will send you the information about those degrees, or make sure you and talk about it, and make sure you have the information about those degrees if that's where your interest might lie. Here on the online IDE here, I pointed at this the other day. Notice there is a Learn tab. And they have lots of tutorials and things like that. So as time allows, this is a very active subject. We learn by doing. So maybe click on some of the tutorials and kind of see what's out there. There are some game tutorials on here. Anybody taking my SDev 148 class the second 8 weeks, which I think is the same time as this one, just the second 8 weeks. One of these, I think it's this one. One of the Pygame tutorials on here we might use in our course, because they do it. Oh no, that's the juggling one. So the not that one. One of them, they do some basic stuff and don't do anything with images, and that's something I plan to do in the game development course. Is It's not an it's not an art class, so you wouldn't be graded over the artwork, but I do ask people to do their own artwork in that class. Like even games made with stickmen are fine if that's all you can draw. But hopefully everybody already sees why it's important to be at least familiar with the graphic software if you're heading in towards game development anywhere. But that's a different class. I just want to make that note. If you go through those tutorials, I had a feeling that the people that are already registered to take game development, what is that, 5 weeks from now, might see that tutorial and click on it. But one of those is currently the second one on the list, because last fall when I taught that class, I used way too hard of a tutorial for our Pi game section. So got to back that off. So there are other game tutorials on there. So if you're interested in games, definitely look at the game tutorials. But the Pi game ones, one of those we will probably see in that class the second 8 weeks. With long explanations and things like that. So there are a lot of programming languages out there. Actually, let me pull up a list here. Most popular programming languages. And I think I need Python. So there's lots of lists like this. This particular one I pulled up here. Instead of asking people to fill out surveys and stuff, this one just uses the bots on the internet to figure out what the most popular languages are. So Python is by far the most popular programming language. So I guess might as well do some quick history stuff here. So back in the 1950s, 1960s, computer science was high level, new research, interesting topics. And they were inventing new stuff all the time and going through things. And as one day in the early 70s, there came a big change. So they were ready to move from their language, named the way scientists do, right? Alphanumeric names. So they had a language, it was B, so it was the second major overhaul. And then it had 3 numbers beside it. 3 numbers like you're probably familiar with, right? The version and release and updates, those 3 numbers we see by software. So it was just B and then those 3 numbers as the scientists doing the research had progressed along. They're like, oh, it's time for a new overhaul. So they moved on to the next letter in the alphabet, big overhaul. After B comes C. They had an interesting idea. So like, up to that point, everything was very specific for the machine. They didn't have good kernels worked out yet. So they had to say, put a lot of that information that we have in the kernel these days into the programming language explicitly. So they just kind of asking questions like, well, what if we don't say what machine we're working on? So they left that spot blank. And we ended up with a language that gives us unrestricted control over any machine we run it on. And some interesting things too. At times, there are times where it's even faster than assembly language, which that's a high level interesting point. People have known about that for 50 years and nobody really has a good explanation on it. It's like a high level language should not be faster than an assembly language anywhere. It's special cases where it is, but still a very interesting thing. So it gave the programmer an easy to use syntax, somewhat easy to use. If you're brand new to programming, it's not going to seem quite so easy, but compared to the programming languages available at that time, it was easier than a lot of the other ones. And unrestricted control on any machine. So it became very popular. An idea developed earlier, something called object-oriented programming, which is much, much better for the human than the machine. It's one of those things, it's kind of bad for the machine, but if the programmer can do 1,000 times more, but only a 10% loss in efficiency, it's definitely worth it. And when it was invented, the fanciest computer in Norway was able to run it. and maybe a couple of the computers in America were able to run it. So it was definitely a pipe dream when it was invented, but by the mid 80s, the average computer could handle that extra stuff that came with doing programming in a format that was better for a human. So they took that popular language that gave us total control and moved it to an object-oriented language. And then that kind of took off and spread. And that was around the mid 80s. So the growth in technology we've seen since about 1985 to today is pretty much all based off the power we get from that language. Unrestricted control over the machine, anything we want to do. Another way to say that is there's a complete lack of warning messages. So if we're about to accidentally destroy our machine, the computer's just going to run that code and destroy itself. And some other drawbacks, some things that could be better. So people started cleaning it up and improved it. And every language above C++ on this list of most popular languages was written with C++. C++ was used to write another programming language that was used to write another programming language. And some of them are 4 or 5 levels down. Like there might be C++ was used to write a language, and then that was used to write another language, and that was used to write another language. And eventually that came down to Python, Java, C#, JavaScript. Those are just a couple steps down from it. But everything more popular than that language was written with that language. And some of the things below it. This is just a special instance of C++. R is something different. R goes all the way back to the beginning. But there's a very powerful language, but almost too powerful. And we had to use it to make other languages that were better for the human to work with. And one of those, everything about it was designed to be easier for the human to work with, which passed a lot more work onto the machine, made everything run slower. So for the first 2 decades or so, it was kind of a novelty. People knew about it and would occasionally do things with it, but it ran considerably slower than most of our other programming languages. So it wasn't that popular, but every year machines would get faster and faster and faster. And then finally, that little bit slower wasn't making a difference. That little bit slower moved from half seconds and sometimes up to even seconds, half seconds down to quarter seconds, and finally got down to milliseconds. And then a lot of people are like, okay, we're going to go with the easy to use language. Then around 2012, there was a big breakthrough in AI, and it involves something that is not time critical, something huge we need the machine to do. So we're not worried about saving a few nanoseconds here and there. We just, we start the machine running the program, and then we go get a cup of coffee and come back later. And for that, pretty much everybody was like, yeah, it's not time critical. We're going to go with the easy to use language. And that really pushed Python up to the most popular language in the world. Everything about it was designed to be easier for the human to do. So that's the one we're going to look at here. So create Python, and it's also the one you will probably see most often because it's the most popular programming language in the world. Wait for this to boot up. And we looked at this the other day. Here's the files we have. These are some background things. You don't need to worry about those in the packager section. So up here, main.py is the script we'll be writing in. And for our class, you probably won't move to others into more scripts, but for those who have had some programming before, more is always acceptable in my class. So if you look at that lab and be like, oh, that's very, very trivial, and you know a lot of programming, feel free to do something interesting. I am fine with that. So like maybe you had some programming courses over at Prosser on your way through high school. Amy and Mike are both amazing at teaching people IT stuff. So if you had the courses from them, then you probably know quite a bit of programming already and can do some interesting things in Python. Feel free to do that for the class, and we're in the learning environment. So try to push yourself, try to learn more as you can. I know it's week 4, so you probably have midterms and other courses. So the alternative to that is if you need to save some time here to spend more time on your midterm in another course, I definitely understand that. So here's where we'll write our code. And another one of the learning tools here, you'll notice there's this examples button that has some Python code started off with, kind of the idea of what it looks like. Then over here on the right is where it runs. We have our console, which is the Python output, and our shell, which is what we're going to talk about at the end of the day today. That's the shell is the operating system control programming language. So after we write our program, we have to go to access the operating system control programming language to tell what's in that onion picture on the board that there's a new high-level language program that it can run. On our IDE here, that one's automated. You can do more if you need to, but it's there if you need to do more, but it'll be automated for anything we do here. Our standard test for a long time is we need to check and make sure everything is configured correctly. And the standard way to do that, it actually goes back to one of the very early Mac or very early Apple commercials. I think it was before they even started calling it Mac. Is print the words "Hello World" to the screen. Oops. I've been typing Java, so I'll keep typing that semicolon. Semicolon is the symbol that means end of instruction. That's important, because in a lot of our languages, we say, okay, we have an instruction, we're going to print. And what are we going to print? We're going to print the words "Hello World," end of instruction. And well, the first thing about Python making it easier for humans is humans would indicate that end by doing a line break, like we do with paragraphs, right? So that's what they put in the language. So instead of a semicolon to mean end of instruction, a line feed means end of instruction. And that's sort of a standard test, because if you can get those words to show up on the screen, then that means everything's configured correctly. You don't want to do a whole bunch of complicated stuff and then discover that you have some configurations off, which obviously should be fine here because somebody else is handling the configurations there on the cloud. And it's a big one used by many, many thousands, actually now probably many, many millions of people. We saw it's even becoming like a social media sort of thing. You can communicate with other programmers on here. But that's the standard test to check our configurations. And now we'll start doing things. But we've been at this for 45 minutes, so probably a good time to take a break. And that way we don't take a break in the middle of things. Does that make sense? That way we don't have to stop in the middle of things. So does 10 minutes sound good?
Yes.
Sounds good.
So 1:45, so at 1:55, we'll come over here and start typing our example, our follow along example. And that way we don't have to break in the middle of something. It's going to be kind of a short day, so that way y'all can go do this stuff yourself afterwards. So I'll see you in just a moment. I'm going to go get some coffee.